So this is horizontal, which means it's going to be opposite. So when I say factor of 1/3, that means multiply by 1/3. But we're not going to multiply by 1/3 because it's opposite. So we divide by 1/3, but guess what? I don't divide by fractions. I don't do it. So you're going to divide by 1/3, but I don't do it. Somebody else is saying it. What do we do instead? You multiply by the what? Yes, multiply by the reciprocal. So yes, we are going to multiply by 3 instead of multiplying by 1/3. Because it's horizontal, we do the opposite. So inside here, we do 3x. So where it says 1/3, I flip it, 3x. So that's my formula. Now remember, if it's inside, that means replace x with parenthesis 3x. So g of x equals, let's see, my original equation is up here, absolute value x minus 3, close absolute value minus 5. So g of x equals absolute value, here's my x, I'm replacing the x with parenthesis 3x. Then I still do the subtract 3, I still close my absolute value, I still close my minus 5. It's just going on the inside of the function instead of around the outside. Now, I'm not multiplying anything with this parenthesis 3x. I can't subtract the 2 because they're not like terms. I can't really absolute value that either because I don't know what x is. So the only thing I can do for this one when I go to simplify it is absolute value, just 3x minus 3, close absolute value minus 5. All I needed to do was just get rid of those parentheses. Sometimes the parentheses are really needed, sometimes they're not, like this one. It just depends what kind of equation you have. So can we check that on our graphing calculator? I keep talking about how to type it in the calculator because I want to make sure everybody's heard it 400 times. If you know how to do it, you can work faster than me. You don't have to stay at my pace. So my first equation is going to be absolute value, x minus 3, outside the absolute value minus 5. My second equation is going to be absolute value, 3x minus 3, and then minus 5 on the outside. And now we talked about what will a horizontal shrink do to the picture. If I came and shrunk you horizontally, it should make it skinnier. So we hit graph and we see if that looks right. Here's my original. Does it look skinnier? Yep. Now, about where it moved, it's because when it squished in, it was like getting closer to the axis. So I wouldn't worry too much about that part. We're just beginning. I'd worry mostly if you're checking it, just that it looks like it shrunk. Okay. So the next one. Write a function h whose graph is a vertical stretch of the graph of f by a factor of 2. So this time we're doing h of x. And this is vertical stretch. Is vertical stretch on the inside or the outside? Outside. So that's the one where we're going to have brackets with f of x. And we're going to do something to the outside of it. Anytime vertical, we start with these. Vertical stretch does not change the number. Vertical, keep the same number. So we multiply by 2. You can either put 2 or you can put 2 times. But we're multiplying by 2. So that's my function. That's my formula. That's the A, yeah. H of x. Now I'm going to apply it to this function. So we're going to do 2 bracket. Now I write the whole function in there. Absolute value x minus 3, close absolute value, minus 5. Whew. There we go. So I had to put my function inside that bracket. Is the bracket needed? It is for this one, because this 2 is going to do what? It's going to distribute. We're going to distribute the 2 in front of the absolute value, and it goes to the minus 5. It goes to both the absolute value and the minus 5. So h of x equals 2 absolute value x minus 3, close absolute value, minus 10. Now if I go to graph this one, the original function was the exact